50 years to Unix. At the time, it was quite a shocking system, and pipes were a really novel invention. A lot of the features that were new and novel in Unix then are commonplace today, but at the time, it was quite a revelation in operating systems. So I was an undergraduate, and was introduced to Unix by a high school friend, Eric Giesen, who had gone to the University of Waterloo instead. And he let me try out the Waterloo system. I persuaded my department to get a Unix license for 6th edition. And then Charles Forsyth helped us upgrade it by providing a lot of the work that had been done at Waterloo. It's important to understand that other systems of the day used considerably larger machines and were a good deal less interesting. So Unix was a real contrast. Ran on smallish hardware, at least at the time, and provided much more elegant and interesting service, I thought. So I followed the progress of Unix through 10th edition. The Unix vendors of the day, this is the late 80s, were making a mess of the system. And I went to interview with Rob Pike in 1986. Actually, no, I went to interview with Bell Labs in 1986. Rob was one of the interviewers. And that was the first I heard about what was to become Plan 9. He was developing software for the NOT terminal, which was a successor to the DMD 5620 in that family, but with a network interface and a virtual memory operating system. A year later, Rob gave a talk at the University of Toronto where I was on staff, and I found it quite inspiring. The vision he presented was essentially that of a Plan 9 terminal. You know, you boot your terminal and you import resources, devices, what have you, from the network, and customize your namespace with those. And then the UK UUG papers were published, and that was, to me, almost as big a jolt as the 1974 CACM Unix paper. It seemed to me that Plan 9 was a continued evolution of Research Unix, but for modern hardware, with the benefit of 20 years of experience, different where it made sense, and designed for distribution. Not necessarily over just Ethernet. It was somewhat network agnostic, and the initial terminals were not. Rob was giving out a single floppy bootable PC distribution at an early 1993 Usenix conference, and I managed to get one, which again was provided a sort of a taste of what the system could be. So in 1994, I came to Bell Labs to work for Ted Kowalski of FSCK fame. He was developing a set-top box called Home Center, and I was providing the operating system for it. We did that. They started making them. Second edition of Plan 9 was issued the next year for a nominal fee, ran on sort of current hardware of the day. Some of the components were built from the LF language, notably the 8.5 Windows system and Acme. In 1995, also, AT&T split. Home Center was canceled. I moved into research Unix support in Lucent, the new company. And most of what had been Center 1127 Computing Science Research moved to Lucent as well. So the initial IBM PCs were solidly uniprocessors. And some companies like Sequent, I think, and certainly Compaq, tried to make multiprocessors out of them. The Pentium Pro was the first one really designed for more than just two processors. And the memory ordering model from the 486 on has been the same according to Intel. But starting with the Pentium Pro, the CPU pipelines and store buffers became long enough to cause problems for Plan 9 sleep-wake up due to the queuing of memory writes. So that got sorted out by Dave Prezzato and Jim McKee mostly. A little help from Intel. Intel guarantees cache coherence, though not DMA coherence, amongst the x86 CPUs in the multiprocessor. And the problem is worse on essentially RISC CPUs that require manual cache flushing. The early ARMs, before V7 certainly, PowerPC systems and so forth. RISC-V systems nowadays tend to provide cache and DMA coherence, which is really, really nice. So, one of the things going on when I first joined labs was Brazil being driven by Phil Winterbottom, partly to try to make the system more efficient, but also to try some experiments, including uncompressed raster graphics. That ultimately got replaced by DevDraw. And yeah, that's eventually Brazil became merged into the main line of Plan 9 before 3rd edition was released. Inferno was a response to the needs of set-top box developers. So it was essentially a Plan 9 kernel with user mode processes replaced by a Linmo bytecode interpreter. It could run on some bare hardware, mostly PCs, or hosted on another OS, including even Windows. Linmo was the primary language for writing applications, influenced by CSP and LF, and the DevDraw interface first appeared there on Inferno. In 1996, I moved to a research department building a multimedia message system named Mesa, which incorporated fax, mail, and voice input and output and conversions amongst all of those, notably OCR faxes, and the ability to take commands by voice. It had no artificial intelligence, deliberately, but a number of people found it quite useful internally, both as a way to dial people. They could look them up in the corporate directory, and also to save voicemail when people called them. So Mesa was based on Inferno, which in turn was hosted on Xeon PCs. Also during that time, I designed and implemented an SMTP replacement called RSMTP. So at about this time, we moved to 100 megabit Ethernet and also switched Ethernet. 100 megabit made switched Ethernet made a much bigger difference in performance than going to 100 megabit. The combination of them was quite nice. Made the network really much more pleasant to use. Phil Winterbottom started a project called PathStar, which was meant to be a combined telephony and IP router, which might have competed with the number 5 ESS phone switches that we typically found in central offices, at that time at least. It was built on a Plan 9 kernel, but ran Inferno. In 1999, my department moved to PathStar, hoping that a Siri-like replacement would be an appealing thing. Siri-like replacement for dial tone, that is, would be an appealing thing. And then in 2000, PathStar was canceled. Phil and Ken Thompson left Lucent, and then in 2001, the dot-com crash happened. They sort of all happened together. I think that's the sequence in which things happened. It was kind of collapsed in my mind into one thing. The Inferno business unit couldn't figure out what to do with Inferno. So they sold it to Vita Nova, Charles Forsyth's company, who went on to make a very serious effort to promote it. Now, once Phil had been the maintainer of the LF implementation, compiler, etc. So when he left, it was replaced in a sense by the addition of libthread in C. And with that, third edition was issued in 2000 under an open source license. A new version of IP 9P, our file server protocol, named 9P 2000, was created, and Ken's file server kernel was adapted to speak it or the old original 9P, now called 9P1. And a few system calls had to be changed to accommodate the new protocol, including a new authentication mechanism, which was supported by Factotum and Sextor. And then Sean Quinlan and Sean Dorward created Venti, a hash address block store which provided deduplication as a side effect, essentially. So third edition, I believe, included all of those things, but it was rather a rudimentary version of Venti. In 2001, Lucent offered to buy out a lot of the senior researchers. Rob and others left for Google. I left for a startup in California. And then fourth edition was issued. Again, with a fairly rudimentary version of Venti. Sean Quinlan, Jim McKee, Russ Cox created a new user mode file server, Fossil, that could use Venti as its block store or could use a disk partition. If you use Venti, you get automatic backup in history and versions and versioning and so forth. I was writing early gigabit Ethernet drivers and bought my own optical jukebox. Venti and Fossil were still pretty new, and I didn't want to rely on them yet. But I wanted to be able to manipulate archives that were bigger than 2 gigabytes. So I modified Ken's file server kernel to implement 64-bit file and device sizes, and I think tripling direct blocks. And a few other people picked it up. And it eventually got turned into a user mode thing. We'll talk about that later. It was feasible in large part, well, in part because Bruce Ellis had greatly improved the code generation on the 386 of most VLONG operations, inlining them, which made their use cheaper and, I would argue, feasible in that context. I also implemented gray listing in SMTPD because I was getting a lot of spam at home. And then in 2004, Dave Rosato left for Google. I'd bought a used Alpha PC and ran Plan 9 on it, 32-bit port, despite being a 64-bit processor. Dave Hogan had ported it while at the University of Sydney before he joined the Inferno business unit. It was a fast machine for its day, although power-hungry. And every model of Alpha was somewhat different. It had loadable microcode that varied with the operating system. The method for accessing the serial console varied with every model, I think. So there wasn't a single porting target that you could use. You pretty much had to pick a single model and port to that, and perhaps, if you were lucky, some other model might be not too different from that one. 2006, Alcatel bought Lucent and became Alcatel-Lucent. Jim McKee recruited me to return to research, to what was left of what had been Center 1127. Russ helped me get the latest Venti, now using libthread, to work and to survive restarts. It had been destroying its block store when it was restarted, I think due to a too small thread stack overflow, if I recall right. So once we had a reliable Venti, I then copied the contents of the old optical jukebox file servers into a Venti store, which was initially on a RAID 5 volume on magnetic disks. don't think at that point we were using the co-RAID device. That history goes back to the end of February 1990, so it's not the very beginning of Plan 9, but it's fairly early, at least from my perspective. I then converted the old file server kernel that I just talked about into a user mode file server, retired the file server kernel and the IL protocol because the file server kernel had been the last software that really relied on IL. And we wanted to have fewer kernels to maintain. Jim had long maintained the PC kernel support, and he created the 64-bit 9K kernel for a U.S. Department of Energy contract. Charles Forsyth produced the C compiler for it, and ultimately the project decided to not use AMD 64s, but to use IBM Blue Jeans with Power PCs. These are supercomputers at various government labs. And those labs only had 10 gigabit per second infrastructure. There was just no other, apparently. You couldn't even plug in a gigabit interface. So we acquired 10G interfaces and drivers, and then we needed a switch to plug them into to test this stuff out. We just could not get one through the internal processes. I banged my head against it for quite a while. Couldn't get 10G switch through the internal purchasing process. So finally I called Arista Networks. I hope I pronounced that right. And the salesman said, some of the guys are afraid you're going to take our switch apart and reverse engineer it. So I had to really promise and beg that we just needed a working switch desperately, because we couldn't buy one internally, that we really would not reverse engineer it. And after a lot of pleading, as I recall it, we got our switch. 9K initially only ran on actual AMD 64s, not even Intel 64 systems, although I eventually fixed that. Tended primarily as a CPU server for use with draw term or other terminals. Largely compatible with Plan 9. I did a bunch of 32-bit ports, mainly looking for something that portable and small that we could carry around and plug Ethernet and mouse, keyboard, and monitor into when we were traveling to other Plan 9 locations. We also had a 24-core Xeon system, probably in conjunction with that same government project. And I found that doing a parallel muck of a kernel on that used so much system time that it was slower than just using 4 processors. We now use semaphores for locking and monitor M-wait for idling, and I think that has probably fixed it. I don't have a 24-core system on hand at the moment, but I believe it probably has fixed it. There were a lot of bootstrap programs proliferating, I noticed. They were getting to be too big to fit in the bottom of memory on the PC. And so I created new ones from a variant PC kernel that used normal PC device drivers, again, reducing our maintenance load. And the new bootstraps are compressed with LZIP. They decompress themselves when they start running, and they can load 386 and AMD 64 kernels. I was a fan of IPv6, tried to improve the support within Plan 9. I think it's reasonably good at this point. We don't do IPv6 DHCP, but I haven't needed it yet. And in 2011, Dennis Ritchie died. He was a friend and a major supporter of Plan 9 as well as Unix and C. And I think he managed to keep C fairly small and simple, at least through the first ISO C standard. Yeah. So in 2014, I moved to Google in Mountain View, California. Alcatel was then shortly after bought out by Nokia. So I bought a pair of TS140 Xeon servers, nice little relatively cheap machines with PCIe slots. They had an integrated Ethernet controller that I could never get to work, but I could add my own. And I got interested in NVMe. I did a driver for that. I wanted to explore 10G Ethernet some more. The initial Intel cards, the X540s, ran really hot. It was always a pair of controllers on the card, and it required cooling. And the TS140s had really loud fans. So in 2019, partly to save my wife's sanity, I bought a pair of quiet Puget Systems Xeon machines and several little PC Engines APU2s, and got 9K working on them. So the 9K that I took from the labs was from 2014. It needed some work. Had to, make it run Intel 64s, fix some odd traps it was getting, upgrade the drivers, and most importantly, I think, make it capable of really using oodles of memory. So my intent here was to give lots and lots of buffering to Fossil and Venti and see how that works, and it works nicely. So I widened the malloc and memset size arguments to be of type uint pointer. This is a no-op on 32-bit systems, so it's a safe thing to do. And I adjusted Fossil and Venti then to exploit basically as much memory as they could get. Not every last bit of it, but a big chunk of it. And I have run those CPU servers on machines with 4, 16, 32, and 64 gigabytes of RAM, so I can confidently assert that it works on all those sizes. The 9K file server is still running on a 32 gigabyte system. There were still a few programs that now on 64-bit systems had too small thread stacks, and I think I adjusted libthread and some of the applications and libregex to try to avoid large thread stacks. A recent fix from Russ has even allowed us to run GhostScript on AMD 64, which I never thought I would see. It's just so baroque and broke and rococo. Nowadays, the kernels I'm building are probably smaller than they were at the labs. I don't put in every driver. I don't put in 10 gigabit Ethernet driver, or sorry, 10 megabit Ethernet drivers, or 100 megabit Ethernet drivers mostly. So L-zipping the kernels themselves allows them to be directly PXE booted without using 9boot or 9load or anything. On a lot of PC hardware, you can discover what you've got by looking at the PCI buses. And so flanline.ini is usually not needed. If it is, you can still read the /cfg/pxe file for your machine if there is one, once the kernel is running. Future times. 2038 is not that far away, and 32-bit times are going to go negative in that year. I've converted the system to use ulongs instead of longs for times, adapted the libc functions that manipulate times, and a few programs that care. The tests for failure of things like the time system call now compare exactly with -1, not just any old negative time. That extends our times to 2106 without having to change all sorts of disk formats, particularly Venti and Fossil. and I extended the time zone files for North America because I knew the rules for North America. I'm trying to rely less on ape. It used to be that awk invoked sh rather than rc, so you had to have ape working and building in order to build a kernel with muck. And I've changed that, so my awk now uses rc. I can build a kernel without having ape working yet. Converted most of the other ape programs, troff and friends, to be native programs. I think only programs that use Unix's select system call really require substantial changes, and I haven't converted any such programs. I also haven't done the PostScript programs or bzip2 or GoScript, Spin, and Tech. Don't use bzip2 and Spin or Tech, so not a huge loss. In 2020, Jim McKee died. He was a friend and comrade in the trenches working on PC stuff. He'd been more or less cheerfully dealing with some of the most awful old PC capabilities of the CPUs and the surrounding supporting hardware from the very beginning. Wrote a lot of fairly tricky code that I am glad I didn't have to write. And in 2020, the Plan 9 Foundation formed. I wasn't involved in the formation of it, but I was asked to be a director. So I served a term as director. During that term, we persuaded Nokia to transfer the ownership of Plan 9 to the foundation, and we've made the historical releases available on the Foundation website, relicensed under the MIT open source license. Lately, I've been working a lot on RISC-V systems. I've got a previous paper about that. Richard Miller did the compiler suite. Extended his existing compiler to 64 bits for me. Hoping that someday we can get off of x86 systems for our servers and including file servers, and use something simpler like RISC-V. We had contact with ETA over Ethernet, but not really much to do with the software. And I was aware that there was a NIX development path for a modified 9K that I didn't really pay a lot of attention to. I don't like jumbo packets. I think they're a really bad idea for sort of the obvious reasons on the slide. What I have done at home, perhaps as an alternative, is to negotiate up to a larger RPC size. I doubled it. And with that, I see about a 30% improvement on large copies. Yeah, Plan 9 is a distributed system. I don't feel that we need a web browser on it. We can run in web browsers elsewhere. Writing a browser is essentially infeasible, and C++ is just beyond comprehension at this point. Every people I worked with or watched work were generally pretty brilliant and generous folks. David Ducolombier has incorporated some of my changes into 9 Legacy, and Adrian Grigor, I hope I've pronounced his name right, is preparing a bootable installer image of my current system. Plan 9 hasn't taken the world by storm, alas. UTF's been successful, and there have been byproducts, Plan 9 ports, and re-implementations. But I think some of the most interesting and powerful parts have not been generally understood, notably the CPU command and the machinery that makes it work. Notably, TLS is a kernel device. It means you don't have to have special TLS read and TLS write separate functions in every program that makes use of the network. You can, you know, hand a process a descriptor that goes through DevTLS and have DevTLS handle the encryption, so that naive programs can nevertheless use encrypted network connections. Operating systems are somewhat religious. I'm going to skip over this. I'm hoping that people will eventually absorb some of the better ideas in Plan 9. It took a long while for even some of the ideas in Unix and its predecessors to be understood, including things like /proc, which in Linux became a dumping ground for all the synthetic file systems for a time. And of course, we must defeat Git. Thank you. The paper has a couple of pages of references. These are not just padding. They're further reading. Some of the references are a bit obscure. Some of the events go back 50 years. Some of you may not have lived through this stuff. So if you want to dive more deeply into it, the references should be treated as further reading. And thank you very much.
All right. So yeah. Does anyone have any questions? If so, please come here.
Okay, so my question might seem pretty obvious. You ended the talk with "we must defeat Git." I don't know, must we?
Well, that's my feeling. There's obviously a lot more to be said about that. I think Git is a really lousy version control system and very bureaucratic and unpredictable. And the bigger problem, though, really is that it enables this idea that you can have a bunch of people working on a single program and sort of almost randomly combine change sets, and voila, you get a working correct program that does what you intended. And I've never agreed with that. Some people may get lucky and it may work for them. I just don't trust the result of that.
All right, so one question from me and one question from the internet.
Mm-hmm.
First one, if I wanted to poke through your changes and maybe pick through and decide which ones I like, where would I go find them?
Probably 9 Legacy for some of them, and I would speak with Adrian Gore. I believe are you in the audience, Adrian? Well, I think he's listening in remotely. Yeah, I have not made a point of breaking it out as individual patches.
Being available somewhere on the internet would be useful.
The tree is available. I can publicize that somewhere. I'm not sure.
That would be wonderful.
Sorry?
That would be wonderful. Oh, go ahead.
Sorry, just going to add, Adrian's trying to produce a somewhat more, I don't want to say stable, well, shaken down version of my tree. I mean, my stuff works fine for me, but I can't try it on everybody's hardware. So he's doing some of that, and upgrading some of the cryptography.
Okay, and the internet question. I noticed there was no mention of 9front. Any thoughts on that?
Don't know a whole lot about it. No, not really.
Right, more questions are coming. What hardware do you recommend for actually trying out the RISC-V port?
I've been using the Star 5 Vision 5 2 pretty successfully. The 2 is significant. Sorry?
I actually have one of those. So where is the software for that?
It's available on my website. I think if you just go to collyer.net/who/Geoff/9, there's a pointer to it. There's a whole tree with compilers and the kernel source and the works.
Okay, cool.
Hi.
You said the historical tree has like private data in it. Is it like only in the home directories, or are there private data somewhere else?
I'm sorry, I had a little trouble understanding you.
Sorry. So the historical, like from
Oh,
1990, you said you cannot share it because some private data is sleeping there. Is the private data
right.
limited to the home directories, or did it somehow slip somewhere else in the source?
There are a lot of things. Home directories are the obvious one. We also, though, have some proprietary source. There were things that Bell Labs licensed from other places. There are some things I'm not really sure of the licensing state of. I mean, it's just everything. And I would want to do a legal review, I think, before releasing any bits of it. People have asked on occasion for little, subtrees like their own home directories, and I found ways to make those available. But I don't really see a good way to make the whole thing available. Sorry.
Understand now. Because there is this initiative called Software Heritage, and I think they would be quite interested in saving that for future historians. So
I'm aware of the Unix Heritage people. Is this a different effort?
Yeah, it's similar. So the Unix Historical Society is one thing, and then you have like a more generic movement of software preservation called Software Heritage Foundation, and they would, like, for example, archive all of GitHub and make sure that the source is still available, like in 50 years. Yeah.
Right. To that end, the Plan 9 Foundation has got the major releases, so that stuff at least will be available, I hope, indefinitely.
Thanks. All right, yeah, looks like that's it. And yeah, thank you a lot again. I think everybody enjoyed getting to learn a bit more about the history here. And we will also make sure that you will get this year somehow. I guess you get
Sorry?
another round of applause. Yeah, we're making sure that we send this here to you somehow. Oh, right. Yeah, you can't
Okay.
see it right now because it's only on the recording. Anyway, yeah, you will also get a little 3D printed blender.
Thank you.
All right. Thank you.
Okay.